Welcome to the second video for the Great Guitar Build-Off 2021. One of the things I mentioned in a previous video was that I was going to build an inline booster for the guitar based on Aion's Photon line booster, which is a clone of Seymour Duncan's pickup booster. One of the things I wanted to do with this build of the circuit was to use my own perf board instead of using the one that comes from Aion. There are a couple of reasons for this. First, this board, as nice as it is really designed to be built into a pedal instead of a guitar, and because of that it has hardpoint connections here for the boost control knob and the mode switch. But the real gotcha is that several of the parts which make up the power supply are down here on this daughter board, which goes along with this big section for the foot switch and the LED indicator. So this daughter board is mostly wasted space, and I would like to avoid that if I can with the guitar. So what I'm going to do is translate this circuit more or less onto this piece of perf board. Here's how that process is going to work. One of the first things I did when I got all the parts in from Mouser was to verify the parts against the parts list from the kit, and to save my sanity later, I labeled each component in the bag. Trying to spot the very tiny writing on electronic components in a big bucket is a giant pain, and I don't recommend it. So anytime I do any sort of electronics project, step number one is to verify that you got everything you ordered and to label the bags accordingly. What I also did at the same time was to measure the leg spacing of each of the components, and I compared that spacing to how it was going to line up on the perf board. You can see that in the case of this little blue capacitor here, that the legs space out in 1, 2, 3 spaces. This is going to become important later as I try to fit all these components on the board in the cleanest way possible. So the next question is how to go about doing that part. Aion graciously supplies the schematic diagram with the documentation for the Photon kit. So I downloaded a piece of electronics layout software called KeyCAD, which allowed me to draw my own version of the schematic like so. They look identical except that I drew literal connections for the power section that were just references on their diagram. And I connected more of the ground lines instead of leaving a whole bunch of them just sort of free floating around. Regardless of that, my schematic is electrically the same as theirs. Once I had this part drawn, KeyCAD then allowed me to produce a PC board layout like this. Having the one from Aion in hand was very useful because I could follow their guiding principles, so to speak, on how they did their layout, so I could get the most efficient placement of the components on the board. The other two things that I was trying to do was to make sure that the connections for the input, mode, power, gain, and output were all along one side of the board instead of being scattered about, and that the power section that I mentioned previously got moved to this space in the center where the mode switch originally was. The other reason to do this in software as opposed to working it out by hand is, well, KeyCAD won't let you screw it up. With this part completed, and knowing that in my case a capacitor takes up 3 spaces and a resistor takes up 5 on the perf board, I could then take some graph paper and work out placements that would give me this same circuit. Obviously things don't line up exactly the same way because this is made to fit the strict perf board spacing, not the custom spacing you get with a PCB. With this, there are some longer runs, these guys up here, that I'm going to connect with jumper wire instead of trying to make very long traces for them. That's kind of asking for trouble. One of the things I realized after I drew this up is that I can get a resistor fit in 4 spaces instead of 5, so I should be able to compress this layout a little bit in this direction and get this down a little smaller. You can kind of see that this is one of those things that takes a little bit of trial and error. If you look closely, you can see eraser marks in various spots along the sheet of paper. The reason I didn't record the creation of this layout or the schematic is that it's just a lot of sitting in front of the computer and dragging parts around on the screen. I didn't figure that was anything that anybody was really going to be interested in seeing. With the how part covered, it's time to rearrange my workspace and get to work. Okay, I have my parts laid out in neat stacks along with the typical complement of tools, including a solder sucker and some wick, because mistakes never happen. Off to the right, maybe a little out of frame, hopefully not, is my digital soldering station. It came with one of those little foam sponge things that you're supposed to dampen to keep the iron's tip clean. They are crap. Don't even bother. Go get one of the little canisters of brass shavings. It is infinitely superior to the stupid little sponge. You can get these from your big international sells everything online store for about $8 to $10 US. It's well worth it. Off camera, I've taken a piece of 800 grit sandpaper and lightly sanded the area that I'm going to build the circuit in. This is just to remove any oxidation or manufacturing residue, which will hopefully make our soldering job easier. I'm going to begin this by coming in a few holes off this bottom left-hand corner because I want to save this screw hole to use for mounting once the circuit is done. Once I have the circuit finished and tested, I'll cut the board down to the size that I actually need and drill some new holes. Okay, here we go. I now have the circuit completely wired up. I've gone ahead and stripped and twisted these leads to make our job easier in the next step, which is to test this and make sure it works like we expect it to. To help with that, I have another gizmo from my electronics toolbox, a breadboard. Now, if you've never used one of these things before, here's the general idea of how they work. The holes for the positive line, or the red line up here, are all connected to each other. The same goes for the negative line, or the blue line below it. Likewise, the same thing works for the pair down here. However, the two sides are not connected to each other. All of the holes in a single column are connected to each other, but not to the column on the other side of the groove here. Lastly, none of the holes from columns 1 through 64, as there is on this board, are connected to each other. Hopefully that made sense. So you can see how this thing can be used to build circuits that are really pretty complicated without having to either solder wires together or twist them together and hope that they all stay in place like you'd expect them to. I also have here a 9-volt battery and connector that's going to be used to power the booster. Input jack, output jack, and then the potentiometer that's going to control the boost level. I don't have switches here for either the bypass or the pickup voicing mode. I don't really need them for this test. I can emulate the same thing just by moving where some of the wires are on the breadboard. First, we'll connect the output jack's ground to the common ground. Then the output hot lead here. This green lead is the output from the booster. The potentiometer, if you look at the pin spacing, is every other one on the breadboard. So I'll place it right about here. The blue lead goes here, green here, and yellow here. Ground for the booster goes to the common ground line, and then next is power. The white wire is the booster's input. And these three are the mode switch. When the white wire is not connected to either of the other two, then we are in the normal mode. When the white wire is connected to yellow, then we are in vintage mode. And when the white wire is connected to blue, then we are in modern mode. Now there's always one wire that wants to be a pain. Okay, now I'm going to connect the input hot lead to the output's hot lead so that the pedal is bypassed. This way we can hear what the guitar sounds like by itself. Hopefully all of this layout makes sense to everyone. Lastly, we need to connect up the battery. Okay, moment of truth. Hopefully there will be no magic smoke. Okay, so far so good. Nothing blew up. None of the components are getting warm to the touch. And I'm reading 9 volts getting to the board with my meter, so the circuit is in fact live. I've got my trusty Yamaha THR-10 here. I've not hooked it up to the computer in order to try and capture any better audio quality than just what the camera mic is going to pick up. All I'm really after at this point is a does it work test. Once the guitar is finished, I will of course make some much better recordings. Stay put. I'm using the same Telecaster that a friend of mine is playing in one of my other videos. I chose this guitar because it has the lowest output of any of the guitars I own, so in theory it will be the closest to the lipstick pickups that I'm going to use for the build. That's the idea anyway. Okay, swapping to the camera's mic now. Here's the guitar stock. The booster is effectively bypassed. Okay, so now I'll move the output here to join up the output of the boost circuit and the input. Yay, sissy cycle buzz. Over here, the boost circuit should now be engaged. Oh, helpful if I would turn on the guitar's volume. Pause for effect. Let's try that again. Okay. And now the boost pedal's engaged. The volume is all the way, or the boost level is all the way down. Here's about halfway. Wide open. So, there's as advertised, there's a significant amount of boost. I would guess that it is in the 25 dB range. Let us now swap and check our other voicings. I'll do that by connecting this disagreeable little wire to here. This should change the voicing to the vintage mode. Yeah, subtly different, not dramatically. Moving over one more space, I should be on the modern mode. Which is definitely darker than the other one. Still a subtle thing, but it is I will call that a successful test. So, yay. Okay, back on the better mic. So the boost works, and on the first shot no less. So I'm going to clean up all of this stuff and get ready to wire up the rest of the wiring harness. I might as well do that at this point. Stay tuned. Looking back at the design that I showed in a previous video, take note of the shape of the control cavity cover. My standard technique for building a wiring harness goes like this. First, I print off the cover plate design at full scale, and then I spray glue it to just a piece of cardboard that I grabbed out of the recycling bin. Then I just mount everything to the piece of cardboard and wire things up accordingly. This is actually the second one of these that I've made, because on the first one I realized the shaft diameter for the boost control pot here was slightly smaller than the ones for the volume and tone control pots. So yeah, I got lucky and caught this before I cut the real one out. So here's what the rest of the wiring harness looks like. On the surface, this looks pretty complicated, but it's not really. Let's examine it one section at a time, so to speak. I'll break down what each section does and then how they all work together. If we look at just this three-way switch at the top, the two potentiometers, the capacitor, and the output jack, and if we imagine that the red and green wires near the back of the upper potentiometer are connected, then this is just a standard three-way switch, one volume, one tone control circuit that we've seen in a bazillion other guitars. Now let's add these two switches. Assuming we're following the color scheme where green is hot and red is the coil tap lead, you can see that these two switches act as coil splits because they selectively connect the red wire to ground. The next switch is the phase reverse for the neck pickup. When the switch is in the down position, the two middle pins are connected to the two upper pins, and thus green is connected to green and black to black, so the pickup is in phase. When the switch is in the upper position, then the middle pins are connected to the bottom two pins, and now green is connected to black and black is connected to green, thus reversing the phase of the pickup. Now for the booster. First, it needs power, but we don't want it running all the time while the guitar is unplugged. That is where the stereo jack comes in. It only connects the two black wires together when a cable is plugged in, connecting the battery's ground to the common ground of the circuit and thus providing power to the booster. Next we have the three wires that run to the boost level control potentiometer, and then the mode switch. The wiring here looks a little weird because I wanted the normal position to be when the switch was up instead of in the middle. So I used a double pole 3-position switch. The wiring works like this. When the switch is up, then the middle pins are connected to the bottom two pins, meaning that the white wire isn't connected to either of the other two. When the switch is in the middle position, then the bottom two left pins are connected and the top two right pins are connected, which means that the white wire is connected to the yellow wire and we have the vintage mode. When the switch is in the down position, then the top two pins on the left side and the top two pins on the right side are connected, so then white is connected to blue, which gives us the modern setting. Lastly, we have the boost bypass switch. I'm using a push button for this. So when the switch is out, then the middle pins are connected to the upper pins. So green is connected to red and white is connected to black. So the output of the volume knob is connected to the jack, and the input of the boost is connected to ground to eliminate noise and the potential for a popping sound when the boost is engaged. When the switch is down, then the middle pins are connected to the bottom pins. The output from the volume control is connected to the input of the booster, and the green output from the booster is connected to the green wire on the output jack. This arrangement is what gives us a true bypass for the booster. If you think of it a bit like building blocks, it makes something that initially looks like electrical spaghetti much easier to understand. Of course, if any of you have any questions, please feel free to message me. I'll be happy to elaborate. I have all my parts laid out in the rough arrangement that I'm going to use them, plus I have coffee. Off camera, I cut the circuit board down to size using a Dremel tool, and I drilled 3 new holes for mounting. And I also filed off the other pads around the perimeter on the front and back, just to reduce the possibility of something bumping into one of them and causing a short. At this point, I need to work out how I'm going to mount the circuit board properly within the control cavity. Whether or not to try and screw the circuit board down inside the body, perhaps mount it up here, or do something else entirely. I've been considering modeling and 3D printing a bracket that would hold the board in place relative to the potentiometers. That way the guitar would be easier to work on. When you took the cover off, everything would come out as a single unit as opposed to having some parts attached to the cover and some to the body. I'm kind of thinking ahead about future maintainability in case you ever need to service the electronics for any reason. So I'm going to do some tinkering in CAD and see if I can make that idea work. It's now a couple of days later, and what I've done off camera is some head scratching and some 3D modeling in Fusion. Here's what I've come up with. Because the shafts on the potentiometers are longer than the thickness of this brass sheet, that meant I could 3D print this plastic bracket which would be held in place by the potentiometers. These standoffs here hold the circuit board in place as well as holding the boost bypass push button. This is just a prototype that I printed in some spare ugly green PLA. I'll reprint the real one in a better color and with a higher infill density. This one is really just a hollow shell. There's no real structural rigidity to it. But this serves as proof of concept that it'll do what I need it to do. So what I can do now that I have this problem solved is wire up the rest of the wiring harness and then just to set this all aside for later. Last time lapse, I promise. Now everything is wired up. We have the positive and negative that will go to the battery clip. Oh wait, I need to solder this ground to the back of the volume pot. No big deal, I can take care of that later. You guys know what soldering a lead to a pot looks like. This ground goes to the output jack. This ground goes to the tremolo claw, or vice versa, it doesn't really matter. This green is the neck pickup going to the 3-way switch. And this red wire is going to be the input coming back to the volume control from the 3-way switch. I'm really kind of happy with the way this all turned out. Everything ended up being relatively neat and clean and all self-contained. Okay, quick review of the controls. We have the master volume, master tone, this is the boost level control, and the boost bypass switch. I'll make a better looking button cap for this instead of using the white plastic one that it came with. Then we have the tone of the boost. This is normal or no coloring of the pickups. Then we have vintage and then modern. Then we have the coil split for the bridge, the coil split for the neck, and lastly the phase reverse for the neck pickup. Thank you everyone for watching. I know this was a long one, but that's what happens when you make something complicated. Oh yeah, I'm supposed to say please like and subscribe at this point, aren't I? Please like and subscribe. I'll see you all later.